Good morning, students. In the CET class, we stopped at problem number 60 in the vector that infinite space, finding the electric field. Now, next problem is, I think in the previous problem, the solution is given in the notes that will be uploaded in the WhatsApp. Alternately, you are taking is distance, centimeters conversion. Please check out the last step. Next, 61. Question number 61. Let's see. A charged particle of mass 5 × 10⁻⁻6 kg micrograms held stationary in the space by electric field of strength 10⁻⁶ volt per meter. A charged particle, mass is given of mass 5 × 10⁻⁶ kg is held stationary in space by electric fields of strength or of intensity of electric fields of 10⁻⁶ volt per meter. That is a million volt per meter, Newton per coulomb, directed vertically downwards. Electric field is vertically downwards. Find the charge of the particle. Find the charge of the particle. G is given in the question as 10 meters per second square. If they given 10, don't take 9.8 around 10. Most of the problems if you take G only 10 meters. Rarely 9.8, but you have to be careful with the options. Sometimes they give 9.8. If they don't give also 9.8, without giving also 10 also 9.8. In theory classes exams, no, compulsory without, if they don't give 9.8 per G. But for the competitive exams, not compulsory. Some cases you have to apply for 10. Here, charged particle, or you can take the liquid rocks having the charges, the charge is Q. Sometimes they will ask you what is the nature of the charges. Electric field is acting downwards direction. This is the direction of electric field. So whenever the electric field is downwards, the force on the positive charge is downwards. Okay. So this is gravity, earth. It will try to move automatically downwards by the weight mg. But now it is not moving downwards; it is moving upwards. Then only it is stationary. Stationary means what? Upward force must be equal to downward force. So electric field is downwards, so the force must be acting upwards against the weight mg. The force, electric force, is nothing but equal to E upwards. So when it is possible, charge should be positive charge means force will be downwards only. So electric field already mentioned downwards. This electric field is downwards dimension. Value is this much. So the charge must be negative charge. Negative charge force is upwards. So we take it as a minus. Minus charge, minus Q is on. This is a negative charge. Minus Q. Okay, automatically the force will be upwards. So you are asked to find out the value of this charge. At equilibrium, stationary, velocity is 0 it is. Mass is 5 × 10⁻⁻6 kg and electric field is 10⁻⁶ volt per meter. G is 10 meter per second square. At equilibrium, net force equal to 0. That means electric force equal to weight. Electrostatic force. Weight is mg is equals to QE. I am taking only the magnitude. Therefore, charge equal to mg by. You are not asked for the sign convention. If they ask sign convention, you can identify that as a negative charge. 5 into 10 to the power of minus 6 into 10 by electric field is 10 to the power of 6. So we will get this as 10 to the power of 6, take it to the numerator. 10 to the power of 6 numerator, minus 12 will take. So 50 into 10 to the power of minus 12 coulombs. It is nothing but pico. 10 to the power of minus 12 is pico coulombs again. Or 5 into 10 to the power of minus 11 coulombs. Like that also you can write down. Sometimes in this question they will ask you how many number of electrons are there. If they ask you number of electrons, no, Q equal to any, you have to find out. In this case, it is not equal. It is a negative charge, so the electrons added to it also, you can imagine. Answer is minus 6, 10 to the power of 6, minus 6, minus 12. 5 into 10 to the power of minus 11 coulombs. In terms of the 5 options, third one, options have to change that to power need to be changed. Check out that side. Next, 62. So, in case they ask you number of electrons, no, Q equal to NE and N equal to Q by E. What is E? This is for number of electrons. It is not in this question. If they ask number of electrons equal to Q by E. 1 by E already know how much it is. 6.2 by 10 to the power of 18. So directly you have to multiply with Q. This is equals to 6.25 10 to the power of 18 into Q value. This Q value is substitute from the previous relation and we get the number of electrons. Next, 62. Electric field charge at a distance of 3 meters from the, it is given. What is the magnitude of charge? This is direct question, you can easily solve it. And I am skipping the problem because E equal to Q by 4 proportional to R square. R is given, E is given. You have to find out Q. It is given, you can check out it. Next is 63. These are simple, but I want to work out 63. Potential difference with the parallel plates is 1 centimeter apart is 100 volts. Potential difference between parallel plates of separation 1 centimeter. 1 centimeter is 100 volts. Find the electric field strength between them. Point electric field strength between them. We are taking the two planes, separated by distance equal to D, connected to the battery. The battery potential difference is, separation is D, potential difference is B, electric field is from plus to minus. This is the electric field. What is the relation is? Between plates. E is equals to B by outside, if they are getting the plus minus charges, electric field is always 0 outside the plates. Unlike charge substitutions, field is 0 outside, only between electric field is present, and the electric field and potential and distance relation is E equal to B by A. So this E is equals to potential difference is, that is data given. Distance is 1 centimeter. Careful, here only the data only converter, and in the questions given for the comparison, here this value only. You have to analyze that way, which you need to convert it, otherwise you may forget that. So that apply it and here only write it to the power of minus 2 meters. and potential difference is 100 volts. Okay, E equal to substitution, E is equals to V by D is 100 by 10 to the power of minus 2. It will become numerator of 10 to the power of plus 2. Plus 2, these also 2 are there. So E is equals to 10 to the power of 4 volt per meter. Other unities Newton per joule is the answer. I didn't give you the options for this. That is the third option. 10 to the power of 4 volt per meter. Next is 64. Next question, 64. 100 joule of work is done when 2 microcoulomb charges moved in the electric fields between 2 points. The potential difference between these plates is places or points we can take, or 2 plates also we can take. And work done is 100 joules. 100 joule of work is done. 100 joule of work is done when 2 microcoulomb charge. When 2 microcoulomb charge is moved between 2 points or plates we can move between 2 points, or you take a capacitor, no, you can take it as a points or plates. Find potential difference between these points. Find the potential difference. Sometimes we give only PD. So we can, in the exam also they may give PD. Okay, PD indicates what is potential difference. Find the potential difference between these points. Or if you take plates, plates. Okay, so you may be given 2 plates. Between these 2 plates, electric field is E, may be given, or potential difference is V, may be given. So V we have to find out. So dV or delta V also will be given. Or between the 2 points, if you have taken A and B, the potential at A is VA, the potential at B is VB. The potential difference is going to be delta V. So between these 2 points, delta V you can also take, or dV also we can take. What potential difference? Delta V is the potential difference between the 2 points. Here also I can take delta V, or V also we can take the potential difference. This is P. This is also P. What is the formula for the work done is? The charge movement is 2 microcoulombs. Okay, work done is 100 joules. You have to write the potential difference. What is the relation for M is? We can take only potential difference as V symbol also, dW also, delta W also, dVR you can also take it. And delta V also we can take. If you take delta V, what then you have to take as a delta W. Answer, delta W is 100 joules. Or you can take simply W also, that is left to your choice. Q naught, I am taking charge at mode is Q naught is 2 microcoulombs. Get with the conversion of this, that is 2 into 10 to the power of minus 6 coulombs. So convert the units. What is the difference? Delta V equal to how much? This is a PD. What is the relation we have is delta V itself is equals to delta W by Q naught from basic definition. In case you could not take the delta W, you can take dV also. dV equal to dW by Q naught, or V equal to W by Q naught. Okay, this is equals to what done is 100 joules by charge moving is 2 into 10 to the power of minus 6 microcoulombs. 100 by 2 is 50. So potential difference is 50 into 10 to the power of 6 volts. or 5 into 10 to the power of 7 volt. That is the second option. It is given in terms of 10 to the power of 7. So it is 5 into 10 to the power of 7 volt. This is the potential difference in the 2 points. Next is 65. This is a little bit more important question. "27 identical mercury drops, each charged to 10 volts and allowed to form a big drop. Then what is the potential of the big drop?" You are taking n drops. How many n drops? N equal to how many is 27 identical drops. 27 identical drops of mercury. Identical drops of mercury, each with voltage 10. Each charged to potential 10 volt. Means on the surface inside, for the charge sphere, it is spherical drops. You are taking mercury drops is spherical. Liquid drop you are taking spherical only. So where the charge is surface. Potential is same on the surface and inside. In this topic, I am going to discuss the problems including the potentials also. Actually, this was the first topic first I mentioned, but now today this class I am going to discuss some potential problem. That means that 27 identical drops of mercury, each charged to potential 10 volts. This is each charge made of mercury, 10 volts. Combined to form a big drop. Combined to form a big drop. Find potential of big drop. The potential of big drop. This theory I need to explain it. That is n small droplets divided into combined to form a big drop. Our big drop break into small droplets. So discuss these similar problems, relations of the coalescences, or the coalescence of the droplets in the surface tension first problem. So here we take several drops. How many are there is n. Each radius is smaller voltage, and potential on the surface is I will take it as a V naught, and electric field is nothing but equal to E naught. Radius is R, electric field is E naught, potential is V naught, and surface charge density I will take it as equal to sigma. Energy, surface energy, U naught. All these you can make the relationship, but this part again we will be discussing later part. So what we will discuss now is only V or E naught also. I will give the combinations. These are all combined. N particles are combined to form a big droplet of radius equal to R and charge equal to Q. This charge, each charge is U naught. Each one is charging U naught. So what is constant in this case? Charge is always constant. So total charge becomes equal to this charge. So Q is supposed to be equal to number of droplets into Q naught. One thing. What is other remaining constant is volume is constant. Total volume. So charge is response outer surface one here also again. So what is the volume of these n droplets is equal to this bigger droplet. But surface area is more for the smaller droplets because this is also exposed outside. So here not exposed. So surface area decreases whenever the charges, small droplets are combined to big. Or bigger droplet broke into smaller droplet means surface area increases. So this one have a more surface area. Surface area I will take it as equals to A naught. Here surface area is A. This is nothing but equal to 4 pi r square each one. And sigma is equals to Q naught by sigma naught is equals to Q naught by area. Surface density. Energy now I am not going to discuss, later we will discuss. And potential formula V naught. V naught is equals to Q naught by 4 pi epsilon into radius. And the electric field formula Q naught by 4 pi epsilon into r. This is each drop, each small drop, called as droplets. But big drop, this is a big drop. For the big drop, radius is r. Okay, then what is the remaining constant? Is volume is constant. So area becomes equal to 4 pi r square. Okay, sigma is equals to Q by A. This Q I am taking as a capital Q. And potential on the surface is equals to capital Q by 4 pi epsilon into capital R. We are going to use this relation. Electric field for the bigger drop is nothing but equal to this total charge by 4 pi epsilon into r square. This is for the bigger drop. What remains constant is volume remains constant, charge is constant. Here 27 number of droplets, number of small droplets are same size, n equal to 27. We must have to write these problems, no. Whatever value given is always given so that we can write 3 to the power of. Power should be 3. So 27 when you get is 8, then I give you. 8 means what? 2 cube we can write. 27 means what? 3 cube we can write. So this you are writing as 3 for these problems. Okay. And volume is constant. Then the small droplet becoming big drop. No. In this case, what is constant is volume is constant. Equal to constant, and total charge is constant. In this process. So we take a total charge Q naught on each charge we have taken. Potential is V naught. Each drop charge and R each drop radius and potential V naught is equals to each potential already given for us. Okay, V naught equal to 10 volts they are given. But what is V naught is equals to Q by 4 pi epsilon into small r. This Q means Q naught. V naught by 4 pi epsilon r. So here volume is constant. Volume. What is the volume is equals to for the small droplets is n into volume of each sphere. Volume of each sphere is 4 by 3 pi r cube is equals to the bigger drop. Bigger drop volume is nothing but equal to 4 by 3 into pi into capital. Cancel this 4 by 3 pi. So get the relation as therefore r cube equal to n into r. R is equals to n to the power of 1 by 3 into small. This relation you need to remember here, and your first topic surface tension also this relation you need to remember. This is very important. Next, this is the potential form. Okay, this is the radius form. Now we want the big drop. For big drop potential. That means on the surface and inside everything. Everywhere is potential V big is equals to V big equal to 4 by 3 pi r cube, this charge Q, and Q equal to n into Q by 4 pi epsilon r into r is the relation, which is can be modified as Q equal to n into Q naught is equals to n into Q naught by 4 pi epsilon naught into capital. Capital is nothing but equal to n to the power of 1 by 3 into small. And write the final formula, you don't have to derive all this. Directly final formula you have to remember all this in terms of the number of turns. Potential generally they ask more times. Very rarely they will ask is for electric field surface charges can be asked. For case and purpose this will be commonly asked. Right? So for other competitive exams, electric field energies also they can be asked, the surface charge density also can be asked. But most frequently asked is for the potentials. N to the power of this capital R is n to the power 1 by 3 into small r. So this becomes what is Q naught by 4 into r is nothing but equal to V naught. I am not putting the value, I am writing down the symbols. So this part becomes equal to V naught. N to the power of 1 by 3 take to the limit, no, n to the power of minus 1 by 3. So what I get is n into n to the power of minus 1 by 3 into q naught by 4% to smaller. Smaller. This part leaving this n. This one, this part you have taken. This part if you have taken, then this is nothing but equal to V naught into V. So what you get the relation is, this is power is 1. 1 minus 1 by 3 is 2 by 3. The result is VB equal to n to the power of 2 by 3 into V naught. This is your V naught is nothing but equal to V small. So that formula you have to remember. So I am writing the final step here. Once again, you don't have to leave all this, write all these steps. Final, this only you have to write. What you have to write is, V equal to n to the power of 2 by 3. 2 by 3 into V small of the potentials. Now n is how much? 27. So write this as potential of the bigger sphere is equals to 27. 27 means what? 3q to the power of 2 by 3 into potential of the each small one is V naught. V naught itself is V small. So small potential is given as 10. So this power cancels. 3 square remains. 3 square is how much is 90 volts. So VB equal to 90 volts. This is the answer. N is only number, units of this potential will be V small. V small I wrote it here because V naught don't remember, you remember in terms of this relationship. VB is equal to n to the power of 1 by 3 into V small. This formula basically. So two things you have to remember. If you require an electric field or any other things, two things you have to remember here. One R, another one is Q. So these two you use, you can modify anything. For example, electric field you are asking. Electric field for the smaller charge surface is Q naught by 4 pi epsilon into smaller q. For bigger one, what is electric field? Electric field is equals to Q by 4 into R square. Q equal to N into small q. Capital equal to this relation. Capital equal to n to the power 1 by 3 to R. Substitute there, you will get the corresponding relations. Next is if you require surface charge density. Sigma equal to Q by A. This Na, this 4 pi and capital R square. Capital is n to the power 1 by 3 into smaller. N they will give you. Sometimes they will give only n on the symbol also they will give. In terms of the symbol also you must be able to write. So here in this relation, you have to remember this relation 1. Okay. Compulsory. And potentially they ask you to remember this relation. Right. Because many times potential only asks. Next one of the problem is this relation. In the notes, when you get this synopsis notes, in that table is there having these R conversions of electrical, but you don't have to remember every formula. You have to remember the basic formula, basic procedure. Then you must be able to solve it because remembering many formulas is difficult. Instead, procedure if you remember, it can be easy. Rather, some formulas you have to remember, not every formula. Next question. Next class we will discuss the problems linked to this potential. 2-3 more problems. 2-3 more problems are there. So we will discuss that in next class.